All right, warming up. The f of x is arcsine of x. That x represents a what? An angle or a ratio? Do you remember? Yeah, it's a ratio. Good. And so f of x, the arcsine of x, either one, they're the same thing. They're going to give you an angle, theta. All right. And remember the PVR for arcsine is what? 1 and 4, right? So it's the half moon. So it's negative to negative pi halves. It's positive to positive pi halves, and it's inclusive, right? We get one or negative one. So you get a positive ratio. You're going to get out a positive acute angle. If you start with a negative ratio, you're going to get a negative acute angle. So f of negative square root of 3 halves is what? Negative pi thirds, right? Negative pi thirds, not 5 pi thirds, right? See the Drake meme up above, right? Not 5 pi thirds, but negative pi thirds. And then f of 1/2, arc sine or inverse sine of 1/2 is positive pi 6. Yep. All right. So there you go. There you go. The principal value range. So hopefully you have that memorized. All right. So we're gonna learn what that is for arc cosine. Yeah, I just did y'all's warm up in 5th period's notes. I hope they don't mind. No big deal.
I'm sure they'll.
Yeah, they'll forgive me. Okay, cool. Well, there's y'all's. All right, so draw a couple of cycles of cosine. We're gonna do the same thing for cosine. Cosine is not 1-to-1. In fact, none of the trig functions are 1-to-1. So we could do what we did for sine for all of them. We're just going to do it over a different interval depending on what the graphs look like. So here's 1, here's -1, right? 2 pi, pi halves, 3 pi halves. I saw some of y'all doing it that way. That's good. -2 pi, negative pi halves, and -3 pi halves. So pi, axis low, axis high, and then working backwards, high, and then connect the dots, quarter cycle, counting intervals. All right, now how can you tell that that's not 1-to-1 immediately by looking at it? It's not 1-to-1 because if it were 1-to-1, it would pass the what? Horizontal line test, yeah. So what we can do then, what that means is it's inverse. When we reflect it across line y equals x, its inverse is not going to be automatically a function. So we can restrict it over a convenient, close to the origin, 1-to-1 interval that includes all the cosine values from -1 to 1. So what is the closest, largest interval that gives that to us? All the values from -1 to 1 that's close to the origin. Not 1 to pi, but this is x equals 0, right? 0 to pi? 0 to pi would work, yeah, because that gives you this interval here. Now, why not -pi to 0? Could that also work? Yeah, it could also work, but why choose negative values when you can use positive values? Am I right? Always be positive. So there you go. That is basically the domain that we restrict. So we're going to restrict cosine of x to 0 to pi. That then, when we reflect it across the line y equals x, I'm not going to show you with that awesome paper flip demonstration that I did last time, but you can imagine what it's going to look like. It's going to be here at not 0, 1, but at 1, 0. And then it's going to be here. And then it's going to be at pi -1 pi. So it's going to, if you put a dot there, there, and there, kind of like on a line, and then you connect it like this. Right, and I'll put the dotted lines. This would snake around left to right if you continued, but we don't look at the dotted line pieces. We look at this. So from -1 to 1, that's what was our range is now our domain. So this is the function inverse cosine of x. And we can also say arc cosine of x with two c's, either one. The domain is going to be the same as it was for arc sine, -1 to 1. Just like sine, the cosine ratios have to be between -1 and 1. Otherwise, you're saying the hypotenuse is not the largest side. What a funny joke. But the range, which I sometimes call the PV range, principal value range, because we already said there could be others. This is the one that everyone that does math agrees upon. It's the way your calculator is programmed. Your principal value range is not negative pi halves to pi halves, but 0 to pi. So up here, you can call this pi, and this would be pi halves. So if you notice, the range is entirely positive. So if you looked at it on the unit circle, instead of going from negative pi halves to pi halves, it goes from 0 to pi. So I don't call this the half moon. I call this the sun on the horizon. You could draw little rays on there if you want. Little rays. The sun on the horizon. I don't know if is it orange or red. There you go. The sun on the horizon, 0 to pi. Cosine is positive in quadrant 1, just like all 6 trig functions are. Cosine is negative in quadrant 2. So if you ever now take the inverse cosine of a positive ratio, just like arc sine, you're going to get a positive acute angle. But what makes it different is if you ever take the inverse cosine of a negative ratio, instead of getting a negative acute angle in quadrant 4, you're going to get a positive obtuse angle in quadrant 2. So that's why back in the day when we were finding the angle, I said if you ever use inverse cosine, you might have to subtract from 180 to find the reference angle. Whereas if you use arc sine, just break the negative off if it was negative and you get the reference angle. Okay. So arc sine is half moon, 1 and 4. Cosine is sun of the horizon. In fact, you can call it cosun instead of cosine if you want. Cosun on the horizon. Yeah, now don't say, do you mean sine is sun on the horizon? No. Sine is, arc sine is sine half moon, right? But it's arc cosun on the horizon. Okay, cool. Let's try it out. Let's do these. Let's do these. Pretend that these are all in the PVR. Find in the PVR. So inverse cosine of positive square root of 3 over 2. What's the answer? Cosine, you can read it like this, either inverse cosine of square root of 3 halves or cosine of what angle in the PVR is square root of 3 over 2. Cosine of what angle is square root of 3 over 2? I'll start you off. Pi. That's right, 6. Cosine of pi 6 is square root of 3 over 2. So the inverse cosine square root of 3 over 2 is pi 6. Easter Bunny leave y'all any pi 6 in your Easter eggs? No? No. Yeah.
Would a honeycomb chocolate bunny count?
Yeah, that's the same thing. Yeah. Nice.
It's the same video.
Hey. Would it be or 11 pi 6? No. After all, what's cosine of 11 pi 6? Square root of 3 over 2, right? But what's wrong with 11 pi 6? Not in the PVR. He's not in the sun on the horizon, right?
Drake would look away.
No, negative pi 6 is also not in the PVR. Negative pi 6 is quadrant 4. That's not in the sun on the horizon. If you take the inverse cosine of any ratio, you will never, ever get a negative angle. Never. It's either positive and acute or positive and obtuse. Okay. Arc cosine of -1/2. So if you want to draw the sun on the horizon first, positive, negative, right? So it's got to be in quadrant 2. So it's going to be pi what is, I'm sorry. Is it your pi 6, pi thirds, or pi 4ths reference angle? That's your pi thirds reference angle. So now what's the angle? It's 2 pi thirds. Yeah, 2 pi thirds. 2 pi thirds. Yeah. Hey, why not 4 pi thirds? Isn't cosine of 4 pi thirds also -1/2? Yes, but what's wrong with 4 pi thirds?
It's not in the sun.
Not in the sun on the horizon. Look, it almost looks like the sun is either stinky instead of hot. Like those are odor marks instead of sun rays. But it also looks like he's winking at you, doesn't it? The sun's got your back. Oh, creepy. Yeah. All right. Inverse cosine of 0. Cosine of what angle is 0? Well, it's not on the x-axis, is it? Cosine is the width. The width is 0 when we squish it horizontally to the y-axis. What's the angle up there? Pi halves. Yeah, that's the answer. What would arc cosine of 1 be? Bonus question. I hope I didn't ask that there. Where is cosine equal to 1? 0. Good. And what is arc cosine of -1? Pi, right? Here's 1, 0. Here's 0, -1. Here's -1, 0. Yeah. So those are the quadrantal angles. Yeah, no big deal. So inverse cosine of 0 is pi halves. Why not 3 pi halves? Isn't cosine of 3 pi halves also 0? Yeah. But 3 pi halves is not in the sun on the horizon, right? Okay. All right. Inverse cosine of 5/7. Is 5/7 a unit circle ratio that we memorized? No. Is it a legal ratio though? How do we know if it's illegal or not? Yeah, it's between -1 and 1, right? That's what you mean? Its magnitude is not bigger than 1. So this angle exists. What quadrant will it be in? Obviously. Well, no. A positive ratio is going to give you a positive acute angle. A negative ratio will give you, it's instead quadrant 1. If that were -5/7, it would be in quadrant 2. Now, if you want to figure out what it is, let's go to the calculator. Okay, and you don't have to get it and grab one. This is the only one we're going to do, so you can just kind of follow along. Let's go ahead and figure out what it's going to be in radians. Okay, so I just gotta choose file. And we just type it in. We're in radian mode, so second cosine, right? That's inverse cosine of 5 divided by 7, and we get 0.775. Is that in quadrant 1? Yeah, because in radians, remember, this is 0 and this is pi halves, which y'all remember is about 1.57. So 0.775 is between 0 and 1.57. If you're curious what it is in a unit that you can appreciate more, you can switch to degrees and you get 44.415, which we know is in quadrant 1. Okay, so there you go. Now we can start combining them. We can start doing inverse cosine of cosine. We can start composing back to back. Now, very similar to what we did up here with sine, we're going to do the same thing with cosine. If you look at this one here, the top one, this x is a what? Angle or a ratio? It's a ratio. We're starting with a ratio. When I take the inverse cosine, it's going to give me an angle theta in the principal value range. I'm then going to take the cosine of that angle. Well, guess what? If I start with a ratio, I'm going to end with the exact same ratio, provided that it's a legal ratio, right? And what are the legal ratios? -1 to 1. So that's the same for sine. They'll always undo each other when you start with a ratio, as long as it's a legal ratio. But when I start with an angle and end with an angle, I got to be careful, because it's only going to completely undo itself if the angle that I start with is in the PVR. So is the angle in the PVR? Question mark. If yes, call it X. If not, find out the other angle that has the same value that's in the PVR. Because remember, there's always two angles within one rotation that have the same trig value. So this is the PVR right here. All right, let's try it out without a calculator. Inverse cosine of 3/5. Is 3/5 in this case an angle or a ratio? It's an angle. How do we know it's an angle? It's next to cosine, right? Not because it has pi in it. It's because it's next to cosine. So I'm going to take the inverse cosine of the cosine of 3/5. Is the answer then 3/5? Yes, because 3/5 is in quadrant 2, which is in the PVR. Now you can also work it out from the inside out if you're unsure. When in doubt, work it out from the inside out. In fact, what is cosine of 3/5? That's right, negative square root of 2/2. And now we'll take the inverse cosine of negative square root of 2/2. And now you're like, oh, cosine's negative in the PVR in quadrant 2. What's the angle in quadrant 2? It's 3/5. So when in doubt, it works, but you can do things a little bit more efficiently when you memorize the PVR. Awesome. Letter B, arc cosine of cosine is 7π6. Hey, arc cosine and cosine are inverse operations of each other, right? So I guess these guys, they just undo each other, right? You pay me $5 and then I pay you $5. We just undid each other. It's right. Wait. Oh, is it D and E? Oh, that makes a good answer choice. Answer choice A, answer choice B, answer choice C would be like chocolate. That's tempting for everybody. Oh, right. 7π6 is not in the sun on the horizon.
It's a little bit past.
It's a little bit past. It's over here. So, yeah, it's in quadrant 3. So here's what you do. If it's in quadrant 3, you know it's got to be in either quadrant 1 or 2, the one we want. Ask yourself this question. In quadrant 3, is cosine positive or negative? It's negative, right? We know what it is. It's negative square root of 3/2. But knowing that it's negative is enough. What other quadrant then is cosine negative in? Quadrant 2. So I want the angle in quadrant 2 that is the same reference angle. So my reference angle is π6. What is your reference angle with π6 in quadrant 2? 5π6. Yeah. So that's how you work it out. You could do it that way, or you could just work it out from the inside out. If you're not sure, right? You could say, okay, cosine of 7π6 is negative square root of 3/2. Got it. Now, if I bring the arc cosine down, now I can say, oh, now in the PVR, cosine is negative in quadrant 2. And what is the angle in quadrant 2 where cosine is negative? Oh, it's your π6 reference angle, which is 5π6. So far, so good, so good, so far? Yeah. Okay. Inverse cosine of square root of 2/2. The square root of 2/2 in this case represent an angle or a ratio? I tricked you, got him, right? It looks like one of our unit circle ratios, but it follows cosine, right? So that's square root of 2/2 radians. Is that angle in the PVR? I hear you, Brady. Here's 0, here's pi. That's the PVR. Square root of 2 is about 1 point something, right? Divided by 2. It's going to be positive, right? And is it less than 3.14? Yeah, of course it's less than 3.14. It's actually less than 1, right? So that angle, I don't know what the actual value is, but I know that it's going to be between 0 and 1. So I know it's in quadrant 1. Is quadrant 1 of the PVR? Oh yeah. So it just undoes itself. So notice that one we can't work from the inside out. I guess the calculator can if you type it in just like that, but I don't really care about the calculator. That's nowhere near as fun. That's like someone saying, hey, I hid Easter eggs for you. Oh, great. Yeah, but I'm gonna let this other person find them for you. Oh, okay. Well, do I at least get the candy? No, that person gets the candy as well. You're like, well, crap, why did I come? And you're like, to watch someone hunt my eggs and eat my candy. That's what the calculator's doing when you do stuff that you don't need the calculator for. All right, how about this one? Cosine of arc cosine of negative 0.5. Is negative 0.5 here an angle or a ratio? It's a ratio because it follows inverse trig. Now, remember, if you're taking the cosine of arc cosine, they're going to undo each other as long as it's a legal ratio. Is that a legal ratio? Is it between -1 and 1? Yeah. So guess what? It will definitely just undo itself. Now, if that had been -1.5, it would have been DNE because that's outside -1 and 1. You could also work this one out from the inside out without a calculator because we know what the answer is. What is the inverse cosine of -1/2? First of all, is it quadrant 1 or quadrant 2? It's negative, so it's quadrant 2. And it's your pi6 or pi3 reference angle where the cosine is 1/2. Third. So now you say, what's your quadrant 2 pi3 angle? 2 pi3, yeah. And now you bring the cosine down. You're like, hey, what's cosine of 2 pi3? You're like, I was just there. It's -1/2, right? Yeah. But you didn't have to. If that had been a -0.6, you wouldn't have been able to work it from the inside out. You'd just be like, oh, -0.6 is legal. Oh, yeah, it's -0.6. All right, and then finally this one here, E, inverse cosine of cosine at 23 pi7. 23 pi7, angle or ratio? It's an angle, not because it has pi in it, but because it follows cosine. It's an angle. Is it in the PVR?
9/7. What? If you take out a full rotation.
Ah. Yeah, let's go off to the side and look at it. 23 pi7 is definitely larger than one rotation. Good, Brady, because 23 is bigger than what number? 14. So it's not much bigger than 14. So let's just subtract out a full rotation. And we'll get the coterminal angle. 14 pi7 gives us 9 pi7. Now we can figure out where 9 pi7 lives. Here's pi, right? Remember this, which is 7 pi7. So up here is 3.5 pi7. So now what's 7 plus 3.5? 10.5 pi7. So now you can figure out where 9 lives. Where does 9 live? Which quadrant? Quadrant 3. Boom. So the quadrant 3 is not in the PVR. No, it is not. It's the legal angle. So here's what you ask yourself, right? In quadrant 3, cosine is what? Positive or negative? Negative. In which other quadrant is cosine negative in? Quadrant 2. That's the one I need to get in. Now remember, we did this before. It's going to have the same reference angle. So if you can figure out the reference angle of 9 pi7, you'll know what your reference angle needs to be. Well, how far is it from 7 pi7 to 9 pi7? 2 pi7. So is your answer 2 pi7? No, that means this is 2 pi7. And our angle needs to be 2 pi7 short of a half rotation. So 7 now minus 2 is 5 pi7. Yes. So you see how this one problem right here combines a little bit of everything that we've done so far this year with trig? It's a really good question. Requires you to know the PVR, requires you to know coterminal angles. It requires you to find reference angle, requires you to know your quadrants where they're positive or negative. And then it requires you to be able to read.
That's the hardest.
And write, yeah. And arithmetic.
And math.
Reading, writing, and arithmetic, and spelling with an R. Reading, writing, and arithmetic with spelling. Arithmetic doesn't even start with an R, but they made it work. You used to only have to know your 3 R's. Get out of high school. Reading, writing, and reckoning.
Right.
Yeah, reckoning. All right. Hey, let's meet inverse tangent today. Inverse tangent. All right, let's do the same thing. Let's draw real quickly. Tangent is the only one you have to know out of the previous section, right? Tangent, remember, has 0, pi halves, then pi, then 3 pi halves, so on and so forth. Negative pi halves, negative pi, negative 3 pi halves. Tangent, remember, also has vertical asymptotes at odd pi halves. So 1 pi halves, 3 pi halves, negative 3 pi halves, and it passes then with an axis point in between. It changes curvature there. So increasing functions, there's one branch. Increasing function, there's another branch. Increasing function, there's yet another branch. So we have 3 cycles of tangent here. There's f of x equals tangent. Remember, the period of tangent is what? Pi. Good. Pi. Every vertical asymptote which occur pi apart, you're going to see another cycle. Is tangent 1 to 1? No. So if we want to talk about the graph of inverse tangent, we want to restrict it to a 1 to 1 interval that's convenient near the origin, 1 to 1, passes the horizontal line test, and includes all of the tangent ratios from negative infinity to infinity. What interval then would work the best, most favorably? Negative pi halves to positive pi halves. Yeah, very good. Much like sine, it's an odd function. And because it's an odd function, it has origin symmetry. So instead of like going from 0 to pi, like we did for cosine, we're going to straddle symmetrically on either side of the y-axis. Negative pi halves to pi halves. So if we took that and reflect it now across the line y equals x, we're going to get the graph of arctangent or inverse tangent. Now, this is the only inverse trig function that you need to know. You don't need to know what the graph of arcsine and arccosine are. You do need to know what the PVR looks like. Here's what it looks like. Y-axis, x-axis. The vertical asymptotes become horizontal asymptotes. Okay. So up here at y equals pi halves, draw that first. You have the old x equals pi halves vertical asymptote, which is now horizontal. And then down here at negative pi halves, you have another horizontal asymptote. And then the graph looks like this. This one you do need to know. This is the graph of inverse tangent. What is the domain of inverse tangent? Real numbers, right? That's what the range of tangent was. And then what's the range of arctangent, also called the PV range, the principal value range? Negative pi halves to pi halves, much like arcsine, right? Except the only difference is in arcsine, were we able to include the endpoints? In arcsine, we were, but for arctangent, we cannot. It's parentheses. I'm over here. Thank you, sir. Oh, I'll send her. Yeah, thank you. So if you want to know on the unit circle, the PVR for arctangent, draw open circles there, but then you can also do the half moon. So much like arcsine and arctangent, for the most part, have the same PVR. You can clump them together. Arccosine on the horizon is the only one that's different. He was already different, remember, because he was the only one that had y-axis symmetry. So he doesn't mind being different again. Peyton, this is for you. Yeah, ASAP. Might want to take your stuff. Yeah. Okay. Now, arctangent is important because it does show up again in the next level. Arctangent actually has end behavior that we could talk about. Let's do that. What would be the limit as x goes to infinity of inverse tangent of x? Pi halves, right? Hop on the graph, head out to the right, get closer and closer to pi halves. And what would be the limit as x goes to negative infinity of arctangent of x? Negative pi halves. Good. It's the same function, just two different names, right? Inverse tangent, arctangent. It actually has end behavior. And by definition, then, because the two one-sided limits go to a finite y value, we know those are horizontal asymptotes at y equals. Okay. So there's arctangent. Yay, arctangent. That's the only one that we need to memorize. Memorize the graph. You got to know the PVR of all three. Arcsine, arctangent are together, minus the endpoints. Arc cosine is arc cosine on the horizon. All right, let's try it out. All right, find inverse tangent of 1. All right, so inverse tangent of 1. Tangent of what angle is 1? Well, just like arcsine, right? If you end up with a tangent ratio that's positive, you're going to end up in quadrant 1. But if you end up with a tangent ratio that's negative, you're going to end up in quadrant 4 with a negative acute angle. So I know inverse tangent of 1 is in quadrant 1, right? Yeah. And it's pi fourths. Could it also be 5 pi fourths? After all, what is tangent of 5 pi fourths? It's 1. But why can't it be 5 pi fourths? Not in the PVR. Not in PVR. Good. So it's just 1. It's pi fourths. Number B, arctangent of negative square root of 3 over 3. Well, what do I know? What quadrant is it going to live in? Quadrant 4. So it's going to be a negative acute angle. So is it negative pi 6, negative pi fourths, or negative pi thirds? How do we deconstruct this one? Well, yeah. Go for it. Yeah. I know arctangent ratio is y over x. Not 1 over pi thirds.
No, if you deconstruct it, the y is 1 and it's over the x, which is pi.
Yes, here's what you want to do. Remember that the square root of 3 over 3 is what we got after we rationalized it. Before we rationalized it, it was 1 over the square root of 3. Or you can re-rationalize it. And also remember I told you that your 2's divide out. So you can actually reconstruct it. You know it's going to be, it came from the 1/2 square root of 3/2, which means that, right, if your x coordinate was square root of 3/2 and your y coordinate was 1/2, that belonged to your what reference angle? Pi thirds or pi 6? That was your pi 6. So guess what the answer is? Well, it's negative pi 6, right? A negative ratio is going to be a negative acute angle. So going backwards, we have to know how we went forward. Do we know how we went forward? We do. We have to be math detectives there and reconstruct the original ordered pair if you don't have it memorized. Okay. All right. Inverse tangent of 0. Tangent of what angle is 0? This one's easy to remember if you just remember what the graph of inverse tangent looks like. It passes through the origin just like tangent itself does, right? So guess what? It is also 0. Tangent of 0 radians is 0, 0. So inverse tangent of 0 is 0 radians. And then arctangent of 30. Is 30 an angle or a ratio? It's a ratio. Is it a legal ratio? What are the legal ratios for tangent? What's the domain of arctangent? All real numbers. Is 30 a real number? Yeah, it is. Is it a unit circle ratio though? No. I don't know what the angle is, but I do know it's going to be in which quadrant. Well, that wouldn't be in degrees or radians. It's just a ratio. It would be in quadrant 1 because it's a positive ratio. So this is calculator time. Calculator. Calculator. Thank you. Thank you. So I'm in degrees right now. So let's keep it in degrees. We'll hit inverse tangent, second tangent of 30. 88.090. 88.090. Got it. And you would want to look to see if your answer is supposed to be in degrees or radians. I would tell you something like this. theta in degrees, if I wanted you to have it in degrees. If we wanted it in radians, it would say theta in radians, okay? So yeah, let me pause this. All right, so same thing here now. Tangent of arctangent of x, they'll undo each other if I start with a ratio, so long as it's a legal ratio. What are the legal ratios? Yeah, all real numbers. So this is always yes. Always yes. It'll always undo each other every time. As long as it's not like 11, right? It has to be like a real number, not like a fake number, not a made up number. It'll always undo itself. But if we start with an angle, it's only going to be in the PVR if it undoes itself. Otherwise, we do the same thing that we did before. Half moon again. All right, last example. Let's try these without a calculator. Inverse tangent of 7 pi fourths. Is 7 pi fourths in the PVR?
Yes. Although it is technically just negative 5/4.
Ah, very good. So it's not in the PVR. It's not in the PVR.
Well, I mean, that
It's not in the PVR. But I want the angle that has the same. I did say it's not. Yeah, so the answer would be negative pi fourths. Right? If you type that into your calculator, it's going to give you negative 45 degrees. All right, letter B. Tangent of arctangent of negative 1000.22. Is negative 1000.22 an angle or a ratio? It's a ratio. Is it a legal tangent ratio? Yes. So will they undo each other? Yes. Always for tangent and inverse tangent. All right. Arctangent of negative 4 pi thirds. Is negative 4 pi thirds in the PVR? No, it's over here in quadrant 2. In quadrant 2 is tangent positive or negative? It's negative. What's the other quadrant where tangent is negative? That happens to be in the PVR. 4, right? Remember, tangent and cotangent are always opposite. So remember, it's going to be the same reference angle. What's the reference angle for 4 pi thirds? Pi thirds. So guess what the answer is? Negative pi thirds, Brady. Negative pi thirds. Negative pi thirds. And the last one. 19 pi 15ths. Do we know where that's at? It's quadrant 3, right? Because here's 15 pi 15ths. This is 19 pi 15ths.
4 pi 15ths.
Well, what is 4 pi 15ths? The reference angle?
Yes, reference angle.
The reference angle is 4 pi 15ths. Now, in this quadrant, is tangent positive or negative? Positive. What's the other quadrant where tangent's positive? Quadrant 1. If you remember, tangent and cotangent are always straight across from each other. So these from geometry are vertical angles. So guess what the answer is? 4 pi 15ths. Yeah. The reference angle is the answer this time. Okay. If you can find the reference angle, remember you have any angle you want. All right. So that's how we do those. We're going to finish tomorrow. And you'll have class time on Thursday to work on your worksheet because I won't be here. I have some doctor's visits again. Mr. Peck will be here though. So while you're working on your worksheet, you can hear some good UFO stories. But tomorrow we're going to finish and you'll work on your worksheet during class Thursday and it'll be due Friday. Okay. No, Friday at 9. Worksheet due Friday at 9 a.m. Okay. All right, we're done. Any questions, comments? All right. Happy belated Easter.